Hi, this is Mrs. Kidman, and in this video, we're going to be talking about how we can rewrite problems that are dividing by a radical. So in this case, we're looking at this problem, and we've got the problem here, 3 times the square root of 5. Let's make that a little bit bigger. So 3 times the square root of 5. Now, as we're looking at this problem, in math, there are some things that we don't like to put in fractions, and it's just because it's kind of gross, and it's kind of weird, and we don't know what it means. So 3 square root fifths, does that even give you any context as to what we're talking about? Of course not. So we don't want to have that square root of 5 in the bottom. We don't want radicals in the bottom of our fractions. We only want whole numbers, right? It would be weird for us to write something like 2 over 0.5. Why in the world would I write that? Why would I not just write 4 over 1? Or for goodness sakes, 4. Why would I have to write 2 over 0.5? I wouldn't. I would never leave my answer there. I would rewrite it till it's in its simplest form. So we want to do the same thing here when we're dividing by radicals. So the way that we get rid of that root 5 is what we're going to do is we're actually going to multiply by a special form of 1. Now that special form of 1 needs to get rid of this root 5 on the bottom. The way we can get rid of a square root, so I have the square root of 7, the way that the number I have to multiply it by to get a number like 7 is if I multiply it by itself, if I square it, so root 7 times root 7, well that's root 49, and 49 breaks down into 7 and 7, obviously. So that is 7. So what we want to do here is we want to change our denominator from being the square root of that number to just that number. And the way we're going to do that is multiply it by 1. In this case, because our denominator is root 5, my 1 is going to be the same root. So root 5, well, if I multiply it by root 5 over root 5, 3 times root 5 equals 3 root 5. Root 5 times root 5 is root 25, and root 25 is the same as 5 times 5, so this is really 3 times the square root of 5 over 5. Now, do you see how this 5 on the bottom makes it just feel a little bit better? Because you're like, okay, at least there's a whole number on the bottom. Whatever is happening on the top is happening, but the bottom, that's a whole number. And that's kind of what we want to do here every time. So we're always going to look, as we go through the examples, we always want to look for the number, that special one that we want to multiply by, to get rid of that radical on the denominator. So in this case, it's going to be that same thing. Our special one is going to be root 5 again because we still have just a root 5 on the bottom. When we do root 3 times root 5, we get the square root of 15 over root 5 times root 5. Again, that's root 25. And we can simplify this right here as getting root 15 over 5. And that's as simplified as it'll go. Now, let's take a look at another example here. Sorry about that. Okay, so let's take a look at this one right here. So this one is 3 times 2 root 5. Now that one's a little bit of a different story. Up here, we just multiplied by the same thing that our denominator was. But in this case, we need to multiply by something that just gets rid of this root 5. So what we're going to multiply by is actually whatever just the radical part is. Even though we have 2 root 5, all I need to multiply it by is root 5. If we multiply it by 2 root 5, it'll work, but then we have to simplify at the end. So look at this. We get 6 root 5 over, well, 2 times 2 is 4. Root 5 times root 5 is 5. And this becomes 6 square root of 5 over 20. Well, 6/20ths, that can reduce to 3/10. So this way does work right here. We do have to do that reducing step. If we skip that and we just multiply by root 5, because all I need to get rid of is that root 5, I end up getting 3 root 5 over 2 times root 25. We know that this is going to be 5, and so we get 3 root 5 over 10. So it's not much easier. It's just one less step, but that's what we want to do there. So let's take a look at one more example, and this one is going to be 8 root 12. So let's take a look at what happens when we multiply this by root 12, just like we have been. And in this case, I get 8 times the square root of 12 over, well, 12 times the square root of 12 times 12 is 12. Now, before I even start, root 12 is not as simplified as it can be, right? This is 2 times 6. 6 is 2 times 3. I can back grab 2. So this is really 16 times the square root of 3 over 12. And 16 over 12, Well, that simplifies to 4 over 3. So really, we can simplify this down quite a ways. And that is how we would divide if we just have a single term on the bottom. Now, if we're dividing and we end up with multiple terms on the bottom, kind of like this one, what we want to do is we want to multiply it by something called the conjugate. So our conjugate here, what that does is it's something that gets rid of the middle term. So think about when we were in chapter 2, and we talked about how x plus x, and we talked about how if we wanted to get x squared minus 4, what we needed to do is get x plus 2 times x minus 2. Now, a lot of people try to do x minus 2 times x minus 2, and when we do it this way, and we multiply it, we get x squared minus 2x minus 2x plus 4, right? And notice how I get this middle term here. But my original problem, I didn't have it. When we're multiplying these, we don't want that middle term. So what we need is we need the conjugate pair. Now a conjugate has the same two numbers, but opposite signs. So whatever our 1 is, we're going to write the exact same numbers here. So a 1 and a root 5. But instead of writing a plus, I want to write a minus. And that's my conjugate pair there. So let's go ahead and multiply this by its conjugate. So as I'm multiplying by its conjugate, we're still going to multiply by 1, but that 1's going to be the conjugate. So here, our conjugate is going to be 1, but instead of a plus, it's going to be a minus root 5. And this is why, if I did a 1 plus root 5 times 1 minus the square root of 5, what happens is 1 times 1 is 1, 1 times negative 5 is negative root 5, positive root 5 times 1 is plus root 5, and then I multiply these two and I get minus root 25. And this simplifies to 1. These cancel out. Root 25 is 5. Did you see how that simplified down into numbers? And what does 1 minus 5 simplify to? Negative 4. So really, that simplifies down into just a number. So that's what we want to do, is multiply it by that. So as I multiply it by that over here, we figured out that our denominator would be a negative 4. Our numerator, we're going to do 3 times this whole thing. So it's got to do that distributive property. So then we get 3 minus 3 root 3. And that is what that simplifies to. And that feels nicer than when we have that radical on the bottom. So we're going to do the same thing again with this one. Now again, we want to multiply by our conjugate. Our conjugate is going to be the same number. So 3, opposite sign, same number. And we're going to do that both on the top and on the bottom. So as we multiply by that conjugate, remember we're going to multiply both sides. Notice how over here, what happened is it became 1 squared minus 5 squared. Really, we're creating that difference of squares when we multiply by the conjugate. So that's what we're doing here. 3 squared is 9. Square root of 7 squared is minus 7. And then we multiply these up here. So multiply those in, and I get 3 root 2 plus root 14. And 9 minus 7, well, that simplifies to a 2. So our answer here, I'm going to erase this part. Maybe. Our answer here is going to be 3 root 2 plus root 14 over 2. And none of those can simplify, and so that is as simplified as our answer gets. Now let's try one more time to use this conjugate. Again, our conjugate, remember, is the same first number. So we're going to multiply by the same first number, so root 7, the opposite sign, so a minus, and then our root 11. And then we're going to multiply by 1, so it's got to be that same thing on top. Now, as we multiply these, what we end up getting is the bottom is root 7 times root 7, which is going to be 7. Root 11 squared, which is minus 11, over negative 2 times root 7, negative 2 root 7, plus 2 root 11. Now, as we simplify this, I get negative 2 root 2 plus 2 root 11 over negative 4. Now, notice how all of these are a factor of 2. So I'm going to factor out a negative 2 because I don't like negatives. And as I factor it out, I end up getting root 2, or not root 2. Oh my goodness, there's a typo there. Root 7, or righto, what do you call that? A mistake. That's what we're talking about. So this is going to be root 7 minus root 11, because remember we factored out a negative 2 divided by 2. And that looks a lot simpler than this thing over here, does it not? So that is how we would rewrite or divide when there's a radical in our denominator. And that is kind of the cap on what we do to use operations or properties on radicals.